So thank you very much. And I was actually told that what you expect from me is both a root workshop summary and a bit about root for the next couple of years. So I tried to squeeze all of this in, and now I need to accelerate because otherwise I'm going to run over my 20 minutes. So let's go. First of all, I'm not going to cover a lot of the details of the workshop. You can find all of that here. There were really excellent presentations, and to prove that, I'm going to just give you a couple of highlights. This root users workshop is something that we do since a long time, actually. Traditionally, the way we do this is that we're trying to get physicists who just want to use root, right? They don't want to talk about root. So we want these physicists to report what their problems are, what they like, and so on. And so traditionally we have this at a special place with a sort of special setup, maybe a nice dinner and so on. And we thought, fine, Fermilab in Chicago, we can get this done there as well. But then 2021, well, I guess everybody knows, right? So that didn't work out, but so we did it in 2022 instead. We had quite some people registered. It was really virtual, but we had in-person meeting rooms so that we could meet some of the people that we know only virtually. We can finally run into them. And we had, because of Zoom fatigue, we had to cram everything into 3 half days. So these 3 half days were really filled to the brim with high quality contributions. You can see by looking at these contributions that an impressive amount of preparation went into these talks, and it's really frustrating that all of them had such short time slots. But I mean, how else can you do it, right? We wanted to cover all the things we covered, and that meant, because of Zoom, because of virtual events, that meant that we had to keep it very short. On the plus side, if you just want to spend a couple of minutes, those are the presentations you want to see from the root workshop, because it's really everything highly compacted, very dense. We presented some of the news from the team. Then we had novice users reporting how they learned root and what the problems are. For us, that's super interesting because that tells us what we need to fix. We have lots of novice users always. We had expert users reporting on their use cases and wishes. And we had almost a whole day of experiments presenting their analysis models, partially also future analysis models. And that included DEW and COMPASS, mu2e, so not just the usual LHC experiments that at CERN are so common, but we explicitly wanted to also solicit feedback and input from the others. We had packages presenting what they are working on and what the challenges are and what their reach is. And then we had some fun things. We actually had somebody presenting how they use Kling for music and how they use root for finance. Now, as I said, I'll just give you a bit of taste of what we were showing at the root workshop regarding root. So if you're thinking about what root is going to do in the future, it's important to understand what root currently is, what's root role, right? Because we are not necessarily changing the role of root. We want to make sure that root's role is fulfilled by what we are doing. So root is relied on by virtually all the geophysics experiments. Yes, we could do more than that. We know this since day one, but let's start with this. There's more than 1 exabyte of data that's entrusted with root, and root serves as a geophysics standard library, as a distribution mechanism. That's also an important functionality, actually, and as a hub of an ecosystem, right? There's all the mini frameworks and so on surrounding it. Now, experts know root and know how to use it. So we're less worried about them. It's the new physicists where root needs to convince, and where we need to make sure that the entry is easy enough. Now, the core duties, the main functionalities of root that the community expects is statistics and modeling, certainly, I/O, obviously. We're providing the math library for much of what we're doing. There is the analysis interface part, and people expect that there is efficient interplay with machine learning, and then graphics. Much of the plots, the publication grade, scientific visualization is still done with root, and we have a long tradition of an event display that also sees continued adoption also in the next generation. Now, we're not just doing this for fun. We have amazing results, actually. And so I'm just going to flash a couple of plots here. You can see the presentations that sort of back these plots in the agenda of the root workshop. But here you see, for instance, why we're providing or working on a succession for T3. Here you see why we're working on GPU acceleration, for instance, for RooFit, or in general also vectorization implementations for RooFit. And here you can see that we can reach 100 gigabytes per second of actual data being crunched. So there is an actual analysis behind this on 2000 cores. So that's with distributed R data frame. Now, what are our plans? With all of these elements, where do we want to go to? So basically, what we're aiming for is to have unbeatable throughput for piping data into machine learning frameworks. That's for training and inference. We want to have something that's versatile, understandable, robust, and highly efficient for analysis interfaces. Here we're using our data frame. That's the one that we offer, and where we believe that it will be able, or is already able, in most cases, to satisfy all these criteria. We want to be providing the IO format for the next 25 years. That's a huge challenge, but that's not so much for analysis. So I'll just skip over that right now. I mean, sure, the analysis, the format is also used for analysis, but there we're way more flexible than, for instance, for long-term data storage for the experiments. So the graphic systems, of course, relevant. We wanted to make it easy to, for instance, plot trigger efficiency or to draw a 2D histogram with categories. All of these things must be simple, and to be frank, simpler than they currently are. And we want to have, we have an advantage here, right? We can design these different parts so that they have an optimal interplay between IO, machine learning, graphics, histograms, and our data frame. Now, you could argue we basically have all of this today, right? The plots I showed, they show you that actually we have our tuple, we have our data frame, and so on. But still, it's a long way for us to go, because what we currently have is pretty amazing, distinct parts. But we need to integrate them, right? We need to make sure that the interplay is as smooth and performant as possible. So we still need to invest. As I'm saying here, we're building the pillars, and we need to build the bridges next. And that's R&D and engineering, actually, something that we are doing since many, many years. So it's not a big change, but still, that's what's going on at the moment and will go on. So root of 2025 ideally is easy to use with a consistent, coherent design, basically as always, only the design is new. And of course, for us, and I hope that everybody's aware of this, import root is like the key for us, right? We want to have root as a seamless Python module for everything we do. So we're not seeing ourselves as a set of C++ libraries that you happen to be able to use also from Python. No, we want to make sure that everything is integrated very well and interoperable. With that, we can actually reap the benefits of our fast C++ core, because that's a huge advantage, right? I mean, the core is amazingly fast, and we can expose this to Python without exposing the C++ nature of the underlying code. Now, there are a couple of other R&D topics that we're going to work on. So for instance, the histograms, that's something that came out of the workshop that's really needed. Autodiff and GPUize the world, as I call it here, that's something that is also a big topic that's ongoing since several years already with root. We want to simplify the install. We want to use C++ reflection to get to simplify some of the dictionary parts. And we want to have a distributed R data frame with some nice new features, for instance, internal optimization of analysis, so we can reshuffle the filters and whatnot to make sure that the analysis runs faster, and that includes GPU offloading of certain parts. Okay, now, given that we're discussing about future of analysis, I thought it's worthwhile to also mention the challenges that we see. Now, we believe that C++ is the right core. At the moment, that's the language that you want to use if you want to write efficient code. It's an expert's language, sadly. And so fewer and fewer students know C++, physicists, that is. It's not something that is very specific to root. All the other C++ projects in high-energy physics see this as well. And we managed to counter it by attracting brilliant computer scientists. But it's important to get this combination of physics and computer science, right? So that's certainly a challenge. With this comes actually something that I find much more worrying. And that is when I started with root, it was common for us to hack root ourselves, right? We made it ours, basically, because there are certain parts that didn't work the way we wanted or missing features, and we implemented them. But this is becoming harder and harder. It's similar to Linux, where you only have a couple of gurus who are able and courageous enough to contribute. And people like me, we're just using Linux, right? So that's a change in perception, and it's certainly something that I don't like, but I don't know what to do about it. We also see a significant investment in a world without root, sort of as a goal by itself almost, but that for us provides a fantastic occasion for benchmarking against alternatives and also to show why root is worthwhile, the trust that the community invests in us. So with this, I'll be heading back to the workshop. If we are looking at these 3 days, I think basically the bottom line is it really hurt to have a virtual event. We are really looking forward to meeting these people and discussing. It's so much nicer to discuss. I'm really sorry I can't be there. I totally realize that it's much more useful to be there in person and be able to discuss. We got really high quality feedback with not just praise, also praise, which is always nice, but also criticism, food for thought, and ideas. So there's quite some fallout, some aftermath from the workshop. Lots of discussions are being spawned. What we did was we knew we had excellent speakers, and we told them, no, just tell us what you think is relevant. So it's really just a wild card presentation, basically, and they went there and said what they thought was useful. And that was very surprising sometimes, but super useful for us. This was followed by a Train the Trainer event. It was the second in a row, or the second event of this kind, with 25 participants. The goal is that we share with the trainers what we have as new material, and we want to hear from trainers what the problems are. And also that was very useful. And I'll just give you a hint of the conclusions. For instance, it seemed to be a topic that Root should be providing at least links to Introduction to Programming. And we found this very curious. We were wondering whether other projects have this as well, because apparently Root is sort of the entrance step for people into ING physics. That's my personal interpretation. And that's why people say, well, probably you should also be providing some Introduction to Programming. We learned that there is certainly no common approach across trainers. Everything from our data frame to T3 is still out there. Alt interfaces play a major role still in training, and the move to new ones is slow. So it's important for the Root team to actually provide material on these new interfaces. Jupyter is the training standard, but it's also not seen as sufficient. So many people still train prompt and scripts and whatnot. And we also learned that the GUI, like the fit panel, are super relevant still, not just for training. People say that's something that's really undervalued. And Root, both from Python and C++, are what people want. So that's good with us. Sort of specific observations are that our data frame is really everywhere. The analysis facilities take that into account. It also plays a role with them. That's now really a general conclusion from the whole workshop, including the Train the Trainer, right? So performance is now at a stage where the focus shifts to ergonomics. We're not as much, the need is not as much seen to compare performance anymore. And so Vary was explicitly praised in that context because it makes, our data frame Vary user makes things a lot easier. The new histogram generation will solve a whole bucket of issues that was mentioned again and again. but really needs to deliver sooner rather than later. So that's something that we just need to see how we reprioritize the super productive people we have so that we can actually get it done. So to conclude, it's always good to see that we have an impact. And these kind of workshops are there to remind us that we can make users' life easier or harder. And that is the main part of our work, right? To have an impact on users. And it's nice to see that when we invest, users actually notice. So the tutorials and the documentation were praised, for instance. There are a couple of things where we can do even more than we're currently doing. And I think bottom line, or one of the main messages, is that performance is good, people are happy, but really what we need to work on is usability now. That's what we want to extend on. We will have recordings. They're currently being edited. And they are going to be accessible also through the timetable. And yeah, I would warmly recommend watching them because there are a couple of really excellent things. Now, actually, Fermilab was the first institution to officially use Root back in, I don't know, 1990 something. So yeah, it was nice to be back there. Just like I told them, I also tell you, thank you very much for caring about Root. Thanks for listening to this, and I'm happy to discuss anything that you might have in terms of questions.
Thank you very much. It was a very nice summary about the workshop. So let me ask if there are questions in the room or in Zoom. I don't see anything in Zoom. On the room, there is one.
Hi, Axel. Yeah, thanks. Very nice talk. I was curious, in your view, kind of going forward, do you think like Python will be the dominant entry point for people? And then, as you say, kind of not only are the interfaces kind of expert level, but maybe even the C++ becomes expert level, and the new generation of students are going to use Python, or do you think that the actual analysis is going to also be in C++?
I don't know. I think I mean, I'm always surprised to hear people having problems with their analysis, which is T-tree draw based. I mean, who am I to expect what the future will bring? Really, I would have not guessed that there is a significant fraction of analyses still using T-tree draw, but it does exist. So my impression is that we would love the community to move much faster than they are, but in reality, people are much slower because they're not doing the analysis for the fun of it, right? They're not doing it to use our interfaces. They're doing it to get the physics results done. So I think we will have the usual mix of things. We will have alt interfaces still around. We will have C++ around. We will have Python. Certainly Python is becoming stronger and stronger, but I don't think it's realistic to say that C++ is going to be completely replaced anytime soon. At least not during the next 5 years. I wouldn't expect that.
There is time for more questions. In the meantime, yeah, I can comment about the C++. There is quite some efforts under the umbrella of HSF, RSHAP, on teaching C++. So it would be very interesting if the training group in particular, can get some feedback on what are the needs for learning C++ beyond the basics, that I think basics are very well covered. It's just, yeah. So it would be interesting if you can provide some feedback.
Yeah, I don't think I'm the right person to talk to there. I think that's really something that we need to hear from the analysts, right? And it's always difficult to get sort of a good measure of what the problems are. I don't have an answer. I agree that would be super useful to know, but I don't know how to get the answer.
Yeah, maybe on this, here's Stefan. We have I have participated in this C++ course from the HSF side. And in the previous installment, it took 3 minutes for all 70 places to be sold out. And then in one other installment, it took 1 hour. Right? So there is a need, obviously, for students who are arriving and they don't speak C++, to teach it. And we get phenomenal ratings. They say, oh, it's so great, and the lecture was so interesting, and finally understand now why I'm doing this in this way, and blah, blah, blah. So I think for the foreseeable future, our community will need C++, and they will also need education. And we have to have the money and the time to do it. And well, by the next workshop, I think we're probably still running C++ course.
This is Lucas again. I had another question. So you had the slide where you said Jupyter is kind of the standard for training, but then it's not maybe used for analysis or like for actual analysis, or maybe I misunderstood. I was curious because Root is investing a lot into this distributed R data frame and Jupyter integrations and so on. And so is that like a fair representation, or would you say that in the future, maybe like generalizing from Jupyter itself, maybe kind of browser-based interfaces are going to be kind of an important topic? It seems like an industry, like with things like GitHub code spaces and so on, we're moving very much into this direction of kind of browser-based interfaces to drive not only local analysis, but very large-scale analysis.
Yeah, that's basically the same question as before, only on a different topic. I don't know what to answer. I can't predict the future. All I know is that we have people using Windows laptops to analyze their data. Sorry, Gordon, if you're listening. It's a wide spectrum, and people use the Windows PowerShell or whatever it's called to the terminal to scripts. Everything is in there, right? So of course it's good for the community to have a certain set of tools which works well, but I mean, this is not my opinion. I wasn't representing my opinion here when I said that Jupyter is seen as not sufficient for analysis. That's the feedback we got at the workshop. People said, look, it's nice to teach Jupyter, but then for actual analysis, you really want to make sure that people understand how they can use root from the prompt and from a script and whatnot. So apparently there is a need in the community to understand both interfaces. That doesn't stop us from providing a good Jupyter interface, of course. That's still something that we ought to be doing, in my point of view.
Might be just interesting to see. I mean, in some sense, Root always has also like a recommended, like for example, you always recommend like R in tuple in the future, not T3 and so on. So I mean, there's like some opinionated like vision that Root has probably, and I was just curious to.
Yeah, that's right. Okay, now I get it. Sorry. So there, one of the anecdotes I can share is that we have a user who wrote a script that moves their mouse once a minute so that Jupyter doesn't kill the connection. I think it's really things like that we need to fix as a community to figure out how to do this. If I understand correctly, the new, what is it called, Jupyter Studio, you know what I mean. That one has fixed it. So I think it's also a question of technology. We just need to move there, and then things become much smoother. But as long as we have fundamental issues like this, it's of course, it's hard to recommend any single solution for everybody.
I'm sorry for interrupting the discussion, but we have to move on. So please say thank you again to Axel. So.